All right. So week two, hopefully we're all set up and ready to go. Um, so far haven't seen too many issues, so I'm going to take that as a good sign. And this week we're actually going to start diving into some more of the fun stuff. I guess you could call it. We're actually going to start using the database. So, um, real quick, just kind of want to touch over week two. So this week two is called a query primer because really it's just like um, a review of the parts that make up a select statement, which is kind of like the bread and butter of the database. You know, you can imagine that the reason we would want to store data is to retrieve it. And so the select statement is kind of like the bread and butter of retrieving data out of the database. Real quick though, before we dive into some more of the content, want to quickly go over, instead of doing a paper this week there is a video. You'll kind of do like a kind of a presentation. It doesn't need to be anything crazy. It's really just like something pretty simple. So anyways, what we're going to do um is basically you're going to pick a website. And really by like a website um it can really be like a web application, a website, something pretty simple. Um and basically what we're going to do is we're going to kind of reverse engineer it. And so well, let's go through an example. So like if I were going to pick one, let's actually use Canvas for an example, right? And it doesn't have to be like a web app. It can be something simple, but something where they have data, or a news site. Let's use a news site. So a local news website for around my parts, svinews.com. So we can see here, not a lot of great news it looks like, but anyways, just a basic news kind of site, where you can kind of like get local news. And you can see that there's like different things going on here, and we're going to talk about that. Really, this assignment is to kind of get things going on how to like conceptualize how the data might be stored on the back end. Now, a lot of people, when they first switched to this assignment, I had a lot of people that would like, design tables or say like, oh, like radio is a table, watch live is a table, podcast is a table. Um, that's not necessarily the case. So basically, the idea behind database design is that we want to condense objects to as few and like objects as possible. So, for example, instead of having a table that holds sports stories and a table that holds radio and a table that holds podcasts, we have one table that's called categories, and it holds rows that say sports, weather, radio, watch live, podcasts, so on and so forth. And then we have another table called a post, and the post has a category ID. So instead of a post can be part of a category, so to speak. And so that way everything's a post that's aligned to a category, not isolated. But we're going to go further down that, but I wanted to kind of start off with that for some context, as we kind of talk through some of the stuff this week. But again, really this project, like, it doesn't have to be perfect. This is really just to kind of get thinking about, how might these be kind of structured? And a good resource that's not mentioned anywhere in the stuff that I like to use, is a resource called schema.org. And I really like it because it has like kind of like open source schemas, so to speak. So like they have like a lot of different types of things, and you can like search for them. So like if we look for like a recipe book, right? Like if I were like to Google like how to make imitation Texas Roadhouse rolls, right? I can it's going to bring up recipes. You could kind of pick a recipe website, and you can see here that it kind of has schemas set up, and a schema is just like a structure of data. So like in this case, a property is a table. So like we have a recipe table, we have a how-to table, bunch of different stuff. So this is a good website where you can kind of come and just take a look. And kind of take a look at how they might put things together, some different schemas, or you can Google like example something database, or you can always look to Sequila for that kind of stuff. Local business, anyways, there's lots. You can kind of get an idea of the different types of things you can do. Anyway, so schema.org is a good resource for this. Let's go. Now shift gears. We're going to jump just a little bit this week, and apologize. I was sick over the weekend, so my voice is not 100%. So if trying to somewhat yell through this. So all right. So there's a lot kind of in the reading this week, but it's not too bad. These video tutorials are really, really handy, but what I would say is take them with a grain of salt, because we're going to go over a lot of this in sequence later. So like later on in the term, we have a whole week on aggregating data. We have a whole week on filters and comparison operators and or logic. So anyways, I would say don't necessarily like think you need to like commit all this. They kind of put it there, I think, as like a FYI for contextual reasons. But what I sent you in the announcement this week, I think is a good, like, hey, just explain what it does kind of a thing, if that makes sense. Because we don't need to know like how to do it necessarily right now. Right now, we just need to kind of understand the structure of a select statement. Which it kind of goes through right here. These are real basic things, but obviously a little bit more info is always nice. But anyways, we're going to dive back into the select statement later. I want to kind of cover the content after kind of some more of the housekeeping items. So the last thing I want to kind of hit, just to kind of put it on the radar, is that there is a couple different options. And I know someone asked about this on the Teams chat. But there's a couple different options as far as the final goes. And I want you to be kind of thinking about it, because it can align really closely with our week 2 paper, or the project that you'll do to make the video about a website. So basically, you can either choose to take a traditional final, which is an exam, kind of a cumulative exam. It literally is a kind of bank of all of the week questions. So basically, the weekly quizzes pull from a bank, and it's also pulls from the same bank. So that's one option, the traditional final. The second option is that you can choose to do a final project. Now, the course is kind of built to encourage you to do the final project. It's what I would recommend. You're going to learn a lot more. Everyone who does the final project says that they learn almost as much doing the final project as they do from the whole course. And it's really not a ton of work, especially because we're going to do some of this stuff along the way. In fact, I kind of have it built into announcements usually, where I'll say like, hey, this is where we should be. I talk about it frequently during these meetings. Excuse me. So anyways, it's really built into the course. So I almost feel like you're going to miss out a lot if you choose not to do the final. The only thing, and I know this is usually what gets most people that end up taking the exam final have all intentions at the beginning of the term to do the final project, but they keep procrastinating and end up, it being too much of a task. and that's not to say I haven't had students that do it all, in like 2 weeks, the last 2 weeks, because I'm sure that's happened. But ideally, like if you take just really not even a lot, if you kind of just like work with us as we kind of do it here, like in these meetings with the course, it'll really be pretty simple. Really not bad at all. So wanted to put it on your radar. Next week, we're going to go in depth and talk about what the actual deliverables are. In fact, I might share a previous recording to kind of just go over all of it. So that way, you have full clarity into what's involved. But I can tell you this much: it's it's a lot easier than you think. Especially if you take it bite by bite. It sounds like a lot all in one thing, but really, like we really have like 11 weeks to do this, and really there's only like 4 deliverables. So if you just take it one deliverable at a time, you really have more than 2 weeks per deliverable, which is quite a bit of time, considering that a lot of them aren't too difficult. All right. And both options are worth the same number of points. You can do both, but you'll just get the highest score of whichever one. You can't take half from one, half from the other, vice versa. Whichever is the highest score will do it. But like I said, on teams, the people who do the final project, I've very rarely seen one that doesn't get 100%, and the only reason that they do is because they just didn't complete the tasks really. But the nice thing about the final project is you can submit them early, iterate them on them if you want. So like, there's no excuse you shouldn't get 100%. So anyways, final project, I would highly encourage it. All right, enough of that, of the housekeeping. Real quick, any questions about final project and we're gonna talk a little bit more about database design here in just a second. But any questions about the final options? Okay. Anyways, the final project is basically you just design a database yourself, of your own design, and you kind of like build the database. That doesn't mean you have to build a full working application. You just got to build the database, and kind of like say like, oh, this is the purpose of this database, and kind of proof of concept that it works essentially. So why I bring that up, to circle back to our weekly project or our paper this week, is that that's essentially what we're kind of going to do, but we're going to look at someone else's and try to decipher how it might work. So anyways, now we're going to kind of dive into kind of going over how we might do that. And I'll go ahead.
So for the final project, would an example be I wanted to do a database of my fishing collection? So I got my boat tackle and my land tackle and fishing poles and tackle boxes, and just design a database out of that sort of thing?
Yep.
That be an example? Okay.
Yep. I've had people do all sorts of stuff. Like I've had people do ones that like, there's one that was just like U2 albums and songs and concerts and stuff. Someone did one that was Magic the Gathering cards, all sorts. The one that I kind of demo all the time over and over, which I should probably switch it up because I'm getting bored of it, but recipes. I actually myself do like a recipe book, because it's one of those things I wish that they would add to Family Search. So like that, like on Family Search, you could just upload recipes, and that way, like if I wanted to go, 100 years from now, someone could go back and say, oh, that's how my great grandfather made this stuff. And I get you could just upload a paper, but it's not the same. Anyways, so so I do a family cookbook, like kind of app is what I do. All right. So yeah, sky's the limit. You can kind of do whatever, but so yeah, it's a lot of fun actually, um, to do it. So we're actually going to kind of take a gander at that, kind of go through it. So, um, I really like to shoot guns. That's one of so I'm just gonna like pick something random here. Um, so I like to actually, you know what? More than I like to shoot guns, I really like snowmobiles. And I ride Skidoo, pretty brand loyal to Skidoo. So I'm just gonna pick a Skidoo website, and we're gonna kind of reverse engineer it, kind of talk about it, and then we'll talk a little bit about select statements. So anyways, there's a lot of different ways you can go about completing this assignment. You can do it just in a spreadsheet, where you kind of come up with um, your table and give it columns, because we don't really have to like define it. We can kind of just, I guess, come up with it. So I'm going to do a little bit of both at the beginning, and then just switch over to what I would prefer method, which is really doing it, which is, I think, easier. All right. So specifically what I'm going to do is, like, if I take a look, there's a little bit you can glean from a website. Now, not all of the menu items like equal a table. Like I said, I've had people do that where they will just say like, oh, here's the menu on the website, so that's the tables. Not necessarily. Um, so I'm kind of looking at this like, obviously, like, they have models of snowmobile, but they also have like accessories, parts, and gear. And then they also have I'm guessing this is like a blog section. Um, yeah, so they have like kind of like blogs. Um, so I'm gonna ignore this for now. And again, you don't have to do the whole thing, just a piece of it. So what I'm gonna do is I'm gonna kind of pick on a couple of these. So I'm gonna use models, parts, accessories, and like this find a dealer section, because that should be enough. But first of all, I'm going to start with models, because there's enough here to kind of go around. So what I'm going to do is I'm going to start creating tables. Now, I know every snowmobile, as we can kind of see here, they have like this 2023 Ski-Doo snowmobile lineup, right? And then we can kind of see like there's these categories within this. So I'm gonna kind of start gleaning this, and maybe we'll just focus on models. In fact, like, we're gonna forget everything else. We're just gonna do the models. So, like, how does Skidoo website hold all this data, right? So what I like to do is I always like to start at the kind of top and then work down in. And that may not make a lot of sense now, but hopefully it does here in a minute. So to me, like, the top of the funnel here is really like the year, right? Every year they come out with different models. And even like with cars and stuff, the year is really important. So the first thing I'm gonna make is called model year. Now, this is where we kind of start getting into syntax just a little bit, because naming conventions are important in SQL. MySQL only lets you do certain kind of names. SQL Server has a different kind of preference. So in MySQL, it's all lowercase with underscores between words. So like model year is one. So that might be one table, and I'm gonna kind of like come over here another one. So I have a model year, and then let's just say I have a model, right? And then I'm gonna call this model category, and so model category. Let's take a look, get some inspiration here. Model category is like this, use sport, utility, crossover, um, trail. Trying to think if there's anything else. Let's just start there. So we have model year, model, and model category. Now I'm going to kind of choose what I might have inside of those tables. So the first thing we need in every table is what's called the primary key. And the primary key usually is just the name of the table underscore ID. So model year ID, model ID, and sometimes you can cheat. Like in this case, I'll do category ID. And I'm actually just going to call this category. Just keep things simple since we're just going to do that. So model year, model, and a category. So I have my primary keys. And you don't have to do this all the way like this, but just so you guys can keep aligned here. I'm just going to do this primary key table name. I'm going to do this there. And then data type, this is obviously an integer, which means it's just a number. And then once we kind of set this up, now we can kind of start getting into the meat of this. So for model year, I'm going to put year, which is just like, you know, the number. It's going to be an integer. I'm going to put a start. Let's do a release date, which is a date. I'm going to do an expire date. So basically like when does like that model year become not the most recent? Essentially, because you know, sometimes that gets a little weird. Where, you know, even though it's the 2023 lineup, you know, obviously like they've been selling this since spring of 2022, right? So I'm gonna put those in there. And let's just keep it like that for now. So now I have my model. Now all this data is just to define the model year. But what we want to do is we want to connect model to model year, right? So what we do is we say, oh, model has model year ID. That way, and I'm going to put foreign key here. A foreign key points to another table. So in this case, model year ID is going to align with the primary key of this table. So that way, just by putting one number here, we're connecting all of this other data. So a model not only has a year, it also has, oh, when was it released? When did it expire? Yada, 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 because it came out with the model year. So now what I'm going to do is I'm actually going to like click into this model and see what we got going on. So every model, you know, obviously has an image. Like even if we go back, it has an image, it has a name, and it has a starting price and a description. So you can see that each one of these have their own description. Now, these websites, they don't just hard code all this. Like this isn't someone opened an HTML file and wrote this. This is actually pulling from a database. So pretty realistic. So now what I'm going to do is it has a name or model name or title. Let's go with name. And that's a string, which in our case is a varchar. And it's got a starting MSRP, which is a decimal 15.2 precision, which we'll get into later, and a description, which is a text, which again, we'll get into data types later. So anyways, then we have a model. But one thing I forgot is our category, because every model should be in a category. And this is where we got to start thinking, can a model be in more than one category? Possibly. And so I'm going to say yes, that maybe it can be in more than one category. So instead of putting category ID here, I'm going to save it and we're going to do something a little funky later. All right. And then for category, I'm just going to give it a name for now. So this is kind of like the base of these tables. And if you want, not that it's necessary, I'm going to throw in like a couple examples here. So like category, category ID and name. You know, we might have something like, what do they have? Deep snow. Deep snow. 2 might be trail and crossover. Trail, and 3 is crossover. Yeah, just kind of name a few examples. A model has model ID, model year ID, name, and let's just stick with that for now, for the sake of time. 2, 3, and we have a Summit, Renegade, and Backcountry. All right, and since we're doing, just gonna go over here and we're gonna call this model year. And again, I'm just gonna year ID. Keep it simple. We're gonna go 1, 2, 3. So if like we went 2021, 2022, and 2023, since we're all in the year 2023, this would just be 3 down the line. So basically, we know the model year based on this because we can connect it and kind of look it up, say, oh, the model year is 3. So we know that really it's 2023. So as you've explored Sakila, you've probably seen this where there's a bunch of numbers that don't mean anything. And the column name means something, but like it doesn't actually store the data. And the reason we do this is so that we can have multiple multiple parameters all connected through one value. Because if we put like 2023 here, we have data duplication, which in this case is just a number, so it's similar. But like, let's say we had category here. Category, right? And let's say that we added a 4th snowmobile and we added the Summit Neo. Now we know that this category is deep snow, right? Capitalized like that. But let's say like someone puts it in and it's like this. Right now, all of a sudden they're not in the same category. We're gonna have all sorts of issues. So we try to like keep that off as much as possible. Then what if all of a sudden marketing comes and says, hey, we want to rename deep snow to mountain, right? Well, all of a sudden now we have to change it in 2 places, right? We have to change it here, and then we have to change it for every row inside the model table. Whereas if we just had foreign keys here, whatever we put here doesn't matter here. It's still connected to the same data. Does that make sense? Does that make sense to everybody?
Yeah, it makes sense to me.
Okay. Cool. So anyways, this is a quick example, and realistically, like if your reverse engineer is like about like this, but a little bit more fleshed out, obviously, because I'm kind of going fast, that's perfectly fine. But really what I want to do is I want to take and show you how to do it in Workbench, because this is, in my opinion, just as easy. And I think it's great learning because it's going to set you up perfect for the final project. And maybe even you could start working on the final project. Like I said, the final project really aligns with the course. So we're jump starting a little bit. But anyways, if we take Workbench and we go to File, New, New Model. So File, New Model, right there. It's going to open up this little tab, and what we can do is we can double click on this add diagram. And an EER diagram or an ERD diagram is an entity relationship diagram. And basically, this is like a nice little interface where we can build and visualize a database, just like what we kind of did in the spreadsheet, but you'll see it actually becomes a lot more clear. So I'm actually going to take and kind of duplicate this. So over here on the left, there's these buttons. And I'm just going to click this table button. And I'm just going to click it. And you'll see it puts a little table here, but it's empty. So I'm just going to double click on it. And it'll pull open this little bottom tab. So again, I'm just going to put model underscore year here. And you can really ignore a lot of this. Really, we're just going to worry about the tables, columns, and foreign keys for right now. So once we kind of have our table named on the table tab, then we're going to go over here to columns and just do what we did over in the spreadsheet. So model year ID. And it'll put it in there. And by default, the first one you put in, it marks as the primary key, which means that it's the unique identifier for every row, and not null. So what we're going to do also is check this auto increment. It's just good practice. That means it's going to count up automatically by itself. Again, we're not going to actually build this, but good practice, because when you build your database, you're going to want to do it. So just good practice. And that's why I kind of bring it up. But the primary key is the unique identifier for every table. It can only exist once. So we mark primary key, and this NN is by default because the primary key obviously can't be empty or else it wouldn't be unique. So anyways, not null means it can't be empty. We've all been in those situations where we're just trying to get to a free download and it says, oh, you have to put in your email, or you're trying to fill out a form and it says, oh, you must have this. That's ultimately what this does. So model year, we have a year. We can change this data type over here to int. Release date, which is a date, and expire date, which is a date. All right, so there's model here. And we're going to just do the same thing again, but this time for model. Model table, model ID, and check that auto increment. Model year ID. And you'll notice it starts to do things for you just a little bit, which is always nice. What else do we have? Sorry, I'm going to pull this down. We had a name, starting MSRP, and a description. And this one's a var chart. Now the little parentheses and the var chart 45, that's just how many characters it can hold. So you can leave them all by default for right now if you want. Completely up to you. If you want to get all into it right now, like we're obviously not going to hold it against you. If you don't know what that is, because we're, like I said, we're getting there. Starting MSRP is a decimal 15.2.
If you did picture in there, what would the data type for picture be? Or image or whatever you want to call it?
Oh, yeah, let's do that. So typically you don't actually store the image in the database. Typically what happens is you store a link to an image. So, like you'll have like a web server where you upload all the images, or some sort of like, network available web served like repository of images. So like, for example, if I were to, I guess this is a link, but like if I were to click on one of these and wait for it, and then say like copy image address, copy image link and paste this, you can see that they have like a specific place on their website where they link to content. And then they have a folder in here. So really they just put like the images somewhere. So we're going to do the same thing. Instead of storing the image itself, which technically is possible, but it becomes cumbersome, we're just going to store a URL link. So basically what we're going to do is we're going to say, we're just going to call it photo URL. We could have like a thumbnail URL, we could have a couple, but we're just going to do that. And the data type would be a varchar. Obviously we want it long, so we're going to do varchar at the max at 255. Great question. There's also a thing called a blob, which is a binary large object, and that is where you could store the actual photo data. But then you have to worry about unwrapping that and basically putting it all back together, which is why oftentimes it's just as easy to store the URL. All right. Yeah, great question though. That is a fantastic question. So now we have our model. But you'll notice that like we don't have these connected in any way. I mean, we see the model year ID, but we actually want to connect these. So what we do is we open up the table that's dependent. So this one has model year ID, so it's dependent on the other one. We're going to click on this foreign key tab. If you click on here, you can just give it any old name. I like to do mine, the table name, FK to kind of signify foreign key, and then just a number, 1, 2, I'll go up as I do them. Then you'll choose which table you want to connect it to. In this case, I want to connect to model year, and model year ID is going to point to model year ID. So you kind of just like say the column from the table I'm in points to the model year ID from this table. And once we do that, now you'll see that there's a line here, and when we hover over that line, you'll notice that it tells you which one's connecting them. So there
And
we
we
go.
use the relationship thing too. That's what we did in the last class. And it's like 1,000 times easier, I think, than what you just did.
Where you use like the button here.
Yeah.
Yeah, and you can use the button if you know the right one. The reason why I do it this way is so that you make sure that when you do the foreign key, because basically when we do the final project, we're actually going to have this generate the code to build it. And so I like using this way because it guarantees that it's right essentially. So
Okay.
that way you don't have problems later. But as long as you know the relationship like type, essentially, and draw the right line with and it's dashed like this, then you should.
Yeah. Okay. Because there's a difference between the dash and solid, so you have to get the right dependency.
Yep. So I do it this way, so that way I can just like build it more manually, so to speak. But yeah, you're welcome to do it however you like. So I'm gonna real quick finish off with my category table. Category. And I'm gonna make mine so a model can be in multiple categories, because like let's say it's a youth, trail or a youth crossover, so to speak. I don't think that's actually the case in this, but I want to highlight a certain type of relationship. So I'm going to build my category table, and this may look really kind of dumb, right? Pretty simple, just 2 columns. And like I said, it's not dumb because versus if we put that in here, like I said, you'd have to change it multiple times. And we're going to show what happens, because what if a model can be in multiple categories? Now, like before you knew about databases, you might put like category 1, category 2, category 3 in model. That gets to be a mess. So what we're going to do is we're going to build a many-to-many relationship. So which again, we're going to talk about this later, but I kind of wanted to show you so that way if you encounter in your project this week, you're like, oh, it makes sense, like, and we can do this. So I'm going to call this a model category, basically the combination of the two tables. And again, we give it our primary key, model category ID, and I'm just going to give it a model ID. Make sure this is an int. Set it to not null, and then a category ID. Not null. All right, and then I'm going to come over here to my foreign keys. I'll just let it name them for me. First, I'm going to connect to the model ID to model ID, and then I'm going to connect to category ID. And you'll notice that this, the way these connect, you'll notice that it has these little crow's foot on one side and then just two lines on the other. This is a one-to-many relationship, meaning that a model can exist multiple times in model category, and a category can exist multiple times in model category. The crow's foot is the many side, and the two dashed lines is the one side. So, for example, if I have model ID 1, it will only exist once in the model table, but in the model category table, it could be in there an infinite number of times, as much times as we have data to hold. And the reason we do this is because this way, I can, like I said, I can have a trail category, right? So the name is trail, and let's actually just do this real quick. Yes, we have trail, right? So I'm going to take this off. Let's pretend we have a category, model category, right? And we have model category ID, and then we have model ID. Scoot over this way just a little bit. And category ID. Now let's pick on a real one. So let's find one. Like, let's say this youth, the MXZ, right? MXZ120. Let's build this. So it is model 5. Model year name, it's 2023 MXZ 120. So we have our model. Now, what we want to do is we want to put that model into two categories. So this just counts up. So just 1, 2, really doesn't mean anything yet to us. And the model ID, well, we're talking about the MXZ 120 model ID 5. So we're going to put a 5 here. And the category, first, we're going to put it in the youth category. Let's build our youth category. So category ID 4, right? Okay, it's in the youth category. Now what we want to do is we want to put that in the trail category. So same model. Well, this time the category ID is going to be in trail. So we could put that snowmobile in that model in an infinite number of categories because of this table. And you can see here, just like we talked about, model 5 exists once in the model table, but it can exist many times in the model category table. And same thing with category. It'll only be defined once here, but it can exist many times here because we could have another trail snowmobile or another youth snowmobile, so to speak. All right. Any questions about that? I mean, and like I said, I don't expect you to be an expert on it. This is really just to take your best stab at it. We're not going to grade you if it's not good, so to speak. We're just grading on really effort at this point. It's really just about kind of getting things going. So does anyone have any questions about real basic like concepts there?
I'm fine.
Perfect. All right. And just to give you a quick rundown, the reason why I saved the actual select statements till the end, I wanted to really cover that because it's just different. The select statements are fairly simple. And there's just a ton of resources out there for them. But I wanted to give a quick example of one of those kind of structures inside of our Sequila database. So inside of our database, we have the actor table. Right. So we have select everything from actor. I better use Sequila. All right. So there's everything from actor. And then we have a film table. And as we know, actors can be in multiple films. And a film has multiple actors, just like in that previous example, a category can have multiple snowmobiles, and a snowmobile can be in multiple categories. Just like this. So in our Sequila database, we have actor and film. And then if you look, we also have this handy dandy table called film actor. So if we select everything from film actor, you'll see that it is just an actor and a film. Right? So now just as a quick like showcase of how this works, if I wanted to see which actors were in which films, we could do something like this. Now we're going to get to it. This is more just FYI so you can kind of see the end result. So I want to see the actor first. Let's see what's in the actor table. So we have first name and last name. First name, last name from actor. So I can just start with this, and then I want to get what film they were in. So what we perform what's called a join. So I left join film. I do that on the primary key is equal to, or sorry, we can't left join film. We have to left join film actor because film doesn't have actor in it. So we're going to join that to film actor on actor ID, just like we kind of did when we were building it, right? And now we have the film ID. So then we can, again, once we kind of build that little doorway, then we can go to the film table, say, okay, connect those. Again, we're not learning this for a couple weeks, but just so we can kind of see that it works. This is why we build it that way. All right, so we have that, and I'm going to order it by, so we can kind of see it by .actor ID, or let's just do last name. All right, so now we can see all of the actors. So Kirsten Ackroyd, this is all the movies she's been in. So we can see all the people in what movies they've been in. But vice versa, we could also see every movie and all the actors in it, right? Just kind of flip it on its head. So anyways, this is kind of like why we build it that way, is so that way when we do our select statement, we can pull data out of it. Oh yeah, I've got 3 minutes. There's one more thing that I really want to cover, and that is the different parts of a select statement. So real quick, I'm just going to use customer table, and I apologize. I'm going to make this quick because I know we're right on time here. So if I select everything from customer, this is about really the most basic select statement you can do is something like select hello world. Right. So this is the equivalent of SQL hello world, is you just select it, right? You can just select a static string. But like really, if you're pulling from a table, you can just select the asterisk, which means everything, all the columns. So when I do select asterisk from customer, we get all of the columns, all of the rows. Right. And so the way this kind of works, so I'm going to kind of layer this on and explain the order in which it executes the statement, because I think it helps conceptually make sense of it. So the first thing we're going to do is we're going to go find where our data is. So the customer table. And I always think of this of like, if you were going to find a book in the library, you're going to go, you're not going to, if you're trying to find a piece of data from the library, you're not going to focus on, hey, I'm looking for this specific answer first. You're going to say like, oh, well, which, part of the library is it in? Is it fiction or nonfiction? Or, some more broad. So the first thing we're going to do is find our data. So if you're thinking about a filing cabinet, let's say we're back in teacher in elementary school, right? And we have cabinets and we have a folder for every one of our students that has all their data in it, right? They have a page in each each kid has a folder and there's a page in there that has various things. And let's say that we have a lot of students and each drawer in a filing cabinet is the last letter of their name. So in this case, we're going to go straight for the cabinet. The first thing we're going to do is get our data. So we might go straight and say, okay, here's filing cabinet A, and this is where our data is. That's essentially what we do in the from clause. So the first thing we're going to do is get our data. And we're going to collect that data and we're going to put it on our desk. And we're all nerds here, so we kind of all get what RAM is. When we select data from a table, we load that data out of physical storage into a RAM on the computer. So first thing first, we got to get the data that we want. And so in this select statement, the first thing that always runs is the from clause, get the data first. And then from here, we select the data. So like if we were pulling, every kid's file out of there, we would, if we're trying to select, let's just say first name, select first name. Let's say, we would pull out everyone's first name and set it on the desk. And that's all we would display, so to speak. But we still have all those files sitting on our desk because that's the data we had to process to get to just the first name. Now, the next thing we can do is we can filter out our data. So that's the where clause. So let's go back to selecting everything because I can't remember the names in here. So I'm going to select everything. So let's just use Williams. So I'm selecting every one of my customers where last name is equal to Williams. So basically, we're going to filter out data. Now we're looking for a specific student or set of students, anyone whose last name is Williams. Oh, in this case, there only happens to be one. Right. So we filter the data. So we get our data, stack it on our desk. The next thing we do is filter out, we only need certain people. So we just take out their folders and then we pull out their cards. So in this case, we go from, where, and then we view the data. And there's a couple more. So and I don't want to get stuck too much on the ones that are more difficult to explain. So just to kind of put it out there, we do a group by possibly, which is where we aggregate stuff. We'll talk about that later. In which case it goes from, where, group by. But to keep things simple, we order by, and let's say, we're going to order by last name first and then first name second. Right. And in this case, it doesn't matter, but basically it goes from, where, order by, and then select in that order. So basically, moral of the story is, even though the select clause goes first, that's the last thing that always happens. It always starts at the from clause and then it goes down back up to select. Really wanted to kind of put that out there because as you're thinking about how that works, I always equate it to if I was going to get data out of a filing cabinet that's organized, how would I do it? And because realistically, the computer's doing the same thing, which is kind of cool to think about. I don't know if it ever talks about it, but it helps me think about it. And so I'll bring that up later on as well. But anyways, so like if we're looking at this, it always starts with the from. So from, where, group by, having, order by, and then select. That's kind of the order. It's not tested on. But anyways, I like to put it out there because to me it helps me think about how it works. Because even though we're not selecting everything, we still have all the data on our desk at our disposal.
When you have two tables, does it go from table A, from table B, then where table A, where table B?
Correct. Yep.
Okay.
Yep. And like I said, we have a whole week. It's either 4 or 5, where we talk specifically about joins. So we'll dive in deep in week 5.
I had a question on the exercise. I think it said that you could do it in groups, but you had to submit on your own. Can you just explain a little bit more?
Yeah. So and really that's the way all of this class works. I don't really have any problem with the exception of the quizzes. So the quizzes need to be done by yourself, but all the other stuff, feel free to like work with each other. But like it says, the only thing is you need to have like your own submission. So, I would hope that maybe you can find someone that you can bounce things off of, especially the exercises, because it's, we can kind of preview it. But it says like write a SQL statement that does this, and and the nice thing is we can test this to try it. But if you want to work with someone, that's great. But you both kind of have to do it, so you just do it in tandem, so to speak.
But can we open this up, write a select statement, email my friend Rick Larrabee, who's in this class, and then get back together? Or once you open this up, I know it said no time limit on it, but is it going to grade it if you hit the back button or something like that? You know what I mean?
I don't believe so. I think it'll save it for you.
Because I was just afraid of opening it and then like not filling it out all the way, get a 0 on it, and like, okay, now I'm done. You know what I mean? Like,
yes. Let me try. Let me try it. Curious if it says like, oh, you can't do that, and maybe it won't work on this test student thing. I'm not sure. But if it does not like it, what you could do is you could always just put it in like a Word doc or something. But wrong one. You could always
as long as
put
you
it
can
in,
reopen it, yeah.
yeah. And I would, I don't know. I've been burnt a couple times on doing stuff on the web, so I always get a little nervous. Resume. So it's saving it. So I think you're
Okay,
good.
cool. Okay.
Cool. Perfect. All right. Cool. Well, I don't want to keep you guys longer. I'm already 6 minutes over. I usually try to keep it to an hour so they don't get too long and boring. So anyways, thanks for being here. If you have any questions during the week, feel free to post on Teams. But otherwise, I hope you guys have a great week, and we'll talk soon.